Alright, let's talk about something called limiting reactant. The nice thing about this one is you already know how to do it. You don't even need to be taught it. And just to prove it, I'm going to give you an example of something and you're going to figure it out for me without me telling you how to do it. So imagine that we are assembling tricycles, and of course tricycles have 3 wheels, 2 pedals, and a frame, and we're ignoring all the other parts just for simplicity's sake. And if I told you that we had 20 wheels in total, 15 pedals in total, and 8 frames in total, and then asked you how many tricycles can I build, complete tricycles mind you. In fact, why don't you go ahead and figure that out right now. So probably if you haven't figured it out, pause the video, finish it, and then start again. But if you haven't figured it out, or as you're figuring it out, you probably did this. You probably said, okay, well, 20 wheels, I need 3 wheels per bike, so that's going to give me a little bit less than 7, so 6 and a bit. Okay, and for 15 pedals, if I divide that by 2, that's going to give me 7.5. So let's basically say 7 complete tricycles. And for 8 frames, well, I just need 1, so that's going to give me 8 tricycles. This is going to run out first. I'm going to run out of wheels first, so that means I can't make any more than 6 trikes. Okay, and you probably did that all by yourself. Okay, that's easy enough, but watch this. I'm going to do this instead now. Let's say I told you that you got a shipment in of parts. You had 45 pounds worth of wheels, 2 cases of pedals, 40 pounds of frames. What's the question or the questions that you're asking yourself right now? You're probably asking, well, how much does one wheel weigh? How many pedals are in a case of pedals? How much does one frame weigh, right? Well, I'm going to tell you that information as well. One wheel has a weight of 2 pounds. We're going to assume they all weigh the same. A case of pedals has 12 pedals in it, so one case is 12 pedals, and then the bike frames, each one is 5 pounds. So with all that information, now I want you to figure out how many complete tricycles can I build. Okay, well, you probably started off by converting your mass of wheels into actual wheels, so 45 pounds of wheels. Each one is 2 pounds, so that, okay, sorry. This is really embarrassing. I meant to say 3 pounds. Sorry. You spent all that time doing that calculation, and now I've totally wrecked it for you. I know. How about we just sort of pause the video? I'll give you a second to redo that calculation. Okay, so 3 pounds per wheel, that equals 15 wheels. And then 2 cases, 12 in a case, this is equal to 24 pedals. And then 5 pounds per frame, this is equal to 8 frames. Okay, and now what are you going to do? Well, you did the same thing you did last time. You divided this by 3, and you said this is going to give me 5 complete tricycles. This is going to divide this by 2, it's going to give me 12, and then this is going to give me 8. And so again, this runs out first, so my answer is 5 complete tricycles. Okay, and so by doing those steps, again, I didn't have to tell you what to do. You already knew what to do, which was to convert to an amount, a universal amount, like a number, aka moles, and then divide by whatever this number here is, which is analogous to the coefficients in a balanced chemical equation. Okay, well, the same is going to work for an actual chemical reaction. The analogy breaks down a little bit because we can actually have more than 1 whole mole of sodium oxide, but for the most part, this is exactly the same process. That is, again, to find out what the limiting reactant is, to find out what's going to run out first. Convert to moles first, big surprise, that's always been our first step anyways. Divide by the coefficient, and finally you're going to figure out the smallest number, and that is your limiting reactant. So keep those rules in mind. And now, given the amounts you see there of sodium and oxygen, can you figure out which one is going to run out first? So in other words, find the limiting reactant. To do that, you're going to convert both those amounts to molar amounts. Okay, so 6.5 liters of oxygen gas at STP, we'll assume. Divide by the coefficients and pick the smallest one. That'll be your limiting reactant. Go ahead and do that. Okay, hopefully you paused your video and figured it out. So this is what you should have got. Okay, so 1.09 moles of sodium and 0.29 moles of oxygen, but then don't forget to divide by the coefficients. And actually, the sodium runs out first. This is a smaller number, okay? Just by dividing by the coefficients there and there, you get 0.27. That just tells you where your starting point is. I recommend that you go back to here, okay, and start again. If you're trying to find what mass of sodium oxide is going to be produced, start with the 25 grams. Don't start with this number here. But anyways, but then from that point, you know that this is what determines uh, the amount of sodium oxide produced. You can do a regular stoichiometric conversion like we did in the last video to figure out the mass of sodium oxide produced. So convert to moles, which is going to be this amount, and then multiply by the mole ratio, which is 2 over 4, sorry, 2 over 4, and then multiply by the molecular mass of sodium oxide. Okay, this is a question like a lab we did in class, but you don't have to be there to have done it. If we react 5 grams of zinc and 95 milliliters of a 1.0 molar solution of hydrochloric acid, what volume will we get of hydrogen gas at STP? What volume are you expecting? So we're dealing with a lot of things: mass and volume of a solution and volume of a gas at STP. So the first thing you're going to do here then is figure out what your limiting reactant is, convert both those amounts on the left to molar amounts, divide by the coefficients after you balance the equation, and then pick the smallest one. That's your limiting reactant. Convert that amount, your limiting reactant amount, into a volume of H2. So take your time, pause the video. I'll show you the solution in 3 seconds. Alrighty, well here we go. Let's first of all figure out the limiting reactant. And once again, I've made another mistake. I apologize. It should be zinc chloride ZnCl2, not just ZnCl. Wow, I'm just batting 1,000 today. Anyways, once you got that balanced, can divide by 65.4 grams per mole for zinc to get you that many moles of zinc, and divide by, well, the coefficient here is just 1. That's easy enough. And then to get moles of HCl is simply going to be N is equal to C times V, but V has to be in liters. So it's 1.0 times 0.095, okay, in liters. So I have 0.095 moles, and I have to divide by 2 the coefficient, so that gives me 0.0475. So this is my limiting reactant. It's the smaller number. What that means is I'm going to start here and convert that into a volume of hydrogen gas. So I'm starting with 0.095 liters of HCl, okay, and there are 1.0 moles per liter. You can do it this way if you like. So now I have moles of HCl. Now I can use a mole ratio. It's 1 H2 for every 2 HCl according to my balance equation. Okay, and then multiply by 22.4 liters in 1 mole. And the moles cancels out there and there. I'm left with liters of H2, and that gives me my answer: 1.06 liters or 1.1 liters to 2 sig figs and of hydrogen gas at STP. And there's your answer there. Okay, so this is going to run out first. So if you did by accident use 5 grams as your limiting reactant and converted that to volume of H2, you would have got a larger amount because there's more there to react, so you produce more H2, but that wouldn't actually work because the hydrogen chloride would run out first. So what you could do is, if you're lost, if you're not sure which limiting reactant, you can convert both amounts to volume of H2 and just pick the smaller one. That would work as well. Okay, and that's it for this video, but I'm going to do one more video showing you how to work out the amount of excess reactant remaining, and then that's it. So this is it for this one.